Alright, in this video we're going to be solving the Pure 1 May June 2024 guest paper. If you haven't watched the video where I explain how we came up with this guest paper, go watch that first before you get into this one. And in this video I'll also be giving you the answers. So if you still want to attempt the guest paper, please do so before you watch this video. Otherwise, subscribe and let's dive right in. Number 1. A line with equation y equals mx minus 10 is a tangent to the curve with equation y equals x squared minus 8x plus 15. Find the possible values of the constant m and the corresponding coordinates of the points at which the line touches the curve. So we are told that the line with equation y equals mx minus 10 is tangent to the curve with equation y equals x squared minus 8x plus 15. So the key word here is this tangent. And so we know that if a line is tangent to a curve, there is only one real root. So what does this mean? In terms of the discriminant, b squared minus 4ac is equal to 0. Okay, so let's get our equations. We've got y equals mx minus 10. And we've got y equals x squared minus 8x plus 15. Let's equate these two equations. So that's mx minus 10 is equal to x squared minus 8x plus 15. So that becomes x squared minus 8x. Let's move these two terms to the right hand side. So that becomes minus mx plus 10 plus 15, and this is all equal to 0. So we end up with x squared minus, we're going to factor out the x over here, so that's 8, and we've also factored out the negative sign, so 8 plus m, and that's x plus 10 plus 15, that is 25, and this is all equal to 0. Now we have said that our discriminant is equal to 0. So we need to evaluate the values for a, b, and c before we can use the discriminant. So a is the coefficient of x squared, which in this case is 1. And then b here is equal to negative 8 plus m. I'm just going to expand or multiply the negative sign through the bracket. So it becomes negative 8 negative m. That's b, and then c is 25. And now we can substitute into our discriminant. Our b is negative 8 negative m, and this is squared minus 4ac. A is 1, and then c is 25, and we know that this is equal to 0. So if we expand this, we get, that's m squared plus 16m plus 64, and then if we expand this, that's negative 100, and this is all equal to 0. And so this simplifies to give us m squared plus 16m, 64 minus 100, that gives us minus 36, and this is equal to 0. If we factorize this, we're looking for factors of negative 36. That will give us 16, so we can do positive 18 minus 2, and that should, yes, that should be correct. And then that means m should be equal to 18, or rather negative 18, and m should be equal to 2. Okay, so they've told us to find the possible values of the constant m. We've done that. Now we have to find the corresponding coordinates of the points at which the line touches the curve. Okay, so to be able to do that, we're going to use the quadratic that we had at this point over here, and we're simply going to substitute the m values that we got. So let's start at m equals 18. So I'm going to write here at m equals, or rather negative 18, I keep saying 18, my apologies. So that would be, again, we're using this equation over here. So that would be x squared minus, that's 8 plus m. M is negative 18, and this is x, plus 25 is equal to 0. And so if we simplify this, this would be x squared minus, we've got 8 minus 10 minus 18 in the bracket, which gives us minus 10. So this ends up being minus 10, which is plus 10x plus 25, and this is all equal to 0. We factorize this, that's x plus 5, x plus 5, and this is all equal to 0, and so x is equal to negative 5, and we can equate our y value using, let's use the quadratic that they gave us, x squared minus 8x plus 15, x squared negative 5 squared minus 8x plus 15, and let's punch this into our calculator. If I can find my calculator, there we go. So that is negative 5 squared minus 8 times minus 5 plus 15, and that gives us 80. Okay, so at m is equal to negative 18, we know that that results in the coordinates negative 5, 80. Right? Now let's evaluate at m is equal to 2. Okay, so at m is equal to 2, we are using the equation, it's x squared minus, I believe that was 8 plus m. Let's just verify. Yes, it's 8 plus m over here. So that is plus m. In this case, our m is 2 plus 2x. And then the term independent of x was the plus 25 is equal to 0. And so this becomes x squared minus 8 plus 2 is 10. So that's 10x plus 25 is equal to 0. And now we simply factorize this. So that would be x minus 5, x minus 5 is equal to 0. So x is equal to 5. And we evaluate our y. And we have x squared minus 8x plus 15. Punch that into the calculator. That is 5 squared minus 8 times 5 plus 15, and that gives us 0. And therefore we know that at m is equal to 2, we get the coordinates 5, 0. So we can conclude that for number 1, we have m is equal to negative 18, or m is equal to 2. And in terms of coordinates, let me close that bracket. In terms of coordinates, we have negative 580, and we have 5, 0, 5, 0. And this would be our final answer for number 1. Let's move on to question number 2. A function f is defined by f of x is equal to x squared minus 3x plus 7 for x is an element of all real values. A sequence of transformations is applied in the following order to the graph of y equals f of x to give the graph of y equals g of x. So first we have a stretch parallel to the x-axis with scale factor 1 over 4. Okay, so we are looking for an expression of g of x in terms of f of x. So if we have a stretch in the x-axis, that means we're going to multiply this x over here. Since it's by a scale factor of a quarter, we're going to write this as 4x. So for the transformation here, we use the reciprocal of the scale factor here. So that's 4x. And then we've got the second transformation, which is a reflection in the y-axis. That means we actually have to multiply that by a negative sign. So let me just erase that and write it properly. So it would be f of negative 4x. So this negative sign is the reflection. This 4 is our stretch in the x-axis. And then finally, we have a stretch parallel to the y-axis with a scale factor of 2. So that's going to multiply over there. So that's g of x is equal to 2f of negative 4x. Okay? And now let's substitute in f of x. So we can write this as g of x is equal to 2. Let's put a big bracket. And then wherever there is an x in f of x, you're going to replace it with negative 4x. So we've got x squared here. That will become negative 4x squared minus 3x. Again, replace with negative 4x. And then finally, we have a plus 7. And then we can close our big bracket. So g of x is equal to 2, and then we've got negative 4x squared, which is 16x squared, plus that's 12x, plus 7. And now let's expand. So we get 2 times 16, which is 32x squared, 2 times 12x, that gives us 24x, and 2 times 7, which is 14. And this would be our final answer for question number 2. Let's move on to question number 3. It is given that the coefficient of x cubed in the expansion of 5 plus ax to the 4 times 7 minus ax is negative 80. Find the value of the constant a. Okay, so we have 5 plus ax to the 4, and we have 7 minus ax, and we're given information about the coefficient of x cubed. Let's start by looking at 5 plus ax to the power 4. And what we want the terms in x squared and the terms in x cubed. Because if you then multiply the term in x squared from this bracket over here, if you multiply it by negative ax, you're going to get a term in x cubed. Then if you multiply the term in x cubed from this bracket over here by 7, you're going to end up with a term in x cubed. So from this expansion, we want the term in x squared and the term in x cubed. And we're going to do that by saying, let's start with 4 choose 2. That means the 5 is going to be squared and the ax is going to be squared, and that's where we're going to get our term in x squared. Plus, let's do 4 choose 3 for the term in x cubed, and the 5 is raised to the power 1, and then the ax is raised to the power 3. And now let's expand. 4 choose 2 is 6, so this is 6 times 5 squared, which is 25. And then here, square the a and square the x, so that's times a squared x squared, plus 4 choose 3, 4 choose 3 is 4, times 5 times a to the power 3, x to the power 3. Okay, and now if we simplify, we've got 6 times 125, which is 150, and that's a squared x squared, and then we've got 4 by 5, which gives us 20 a cubed x cubed. Okay, so these are the terms in x squared and x cubed coming from this, the expansion of that. So we can now go on and replace this bracket with the terms in x squared and x cubed, so that it looks like this: 150 a squared x squared plus 20 a cubed x cubed, and we're multiplying by this bracket over here, that is 7 minus ax. And remember that we're looking for the term in x cubed. So to get that, we have to multiply this term over here by this term over there. So we have 150 a squared x squared multiplied by negative ax, plus we can also get a term in x cubed by multiplying this term by this term. So that's 20a cubed x cubed multiplied by 7. Okay, now let's simplify that. So that is negative 150 a cubed x cubed. plus we've got 20 times 7, so that's 140, and this is a cubed x cubed. Factor out the x cubed, so it's negative 150 a cubed plus 140 a cubed x cubed. So if we simplify inside the bracket, we have negative 150 plus 140, so that's negative 10 a cubed, and this is x cubed. So this part over here represents the coefficient of x cubed. And if we go back to our question, we are told that the coefficient of x cubed is negative 80. So we can equate the part inside the bracket to negative 80. So negative 10a cubed is equal to negative 80. And now divide both sides by negative 10. So a cubed is equal to 8. And the third root of 8 is equal to 2. And therefore we can conclude that a is equal to 2. And that would be our final answer. Moving on to question number 4. A large industrial water tank is such that when the depth of the water in the tank is x meters, the volume Vm cubed of water in the tank is given by V is equal to 167 minus 1/3 times 4 minus x cubed. Water is being pumped into the tank at a constant rate of 2.4 cubic meters per hour. Find the rate of increase of the depth of water when the depth is 2 meters, giving your answer in centimeters per minute. Okay, so we are told that the depth of the water in the tank is x meters, and we also want to find the rate of increase of the depth. So since this is rate, and we are checking the rate at which the depth is changing, and the depth is being represented by x, we can write this as dx dt. This is what we are looking for. Now the information that we are given an equation for volume. Volume is equal to 167 minus 1/3 4 minus x cubed. We are given water is being pumped into the tank at a constant rate of 2.4 cubic meters per hour. Since water is being pumped into the tank, it means that the volume is changing, and we're told that this is at a rate of, so we represent this as dv dt since it's the rate at which volume is changing, and this is equal to 2.4 cubic meters per hour, 2.4. And we want the rate of increase of the depth of water at a depth of 2 meters, so x is equal to 2. Okay, now that we have written down all the information that we have been given, let's now work to evaluating dx dt. So we're going to start off by creating a chain rule that will help us get dx dt. So we're going to use this dv dt that we have here, and we're going to use this equation that we have over here. So dx dt, we can start with dx dv. So dx dv is going to come from this volume equation. When we differentiate it, we'll get dv dx, and if you invert dv dx, you get dx dv. You see that in a minute. And then if we multiply this by dv dt, which is over here, dv dt. Okay, that's our chain rule over here. What we need to evaluate is dx dv, and like I said, it's going to come from our volume equation. So v is equal to 167 minus 1/3 times 4 minus x cubed. Let's differentiate to get dv dx. dv dx is equal to, this is a constant, so it disappears. Negative 1/3, bring down the 3 times 3, and that's 4 minus x to the power 2. And if you differentiate negative x, you get negative 1, so multiply by a negative 1. So that means dv dx is equal to, the 3 and the 1/3 will cancel out, and then the negative sign and the negative 1 cancel out. So we have 4 minus x squared remaining. Okay, and we're told that this is all happening at x equals 2. So let's evaluate dv dx at x is equal to 2. So dv dx is equal to, that is 4 minus 2 squared, which is the same as 2 squared, which is 4. So since dv dx is equal to 4, we can write 4 as 4 over 1. Now we want dx dv for our chain rule. So to do that, we're going to flip our fraction. And what you do on one side, you do on the other side. So that means dx dv is equal to 1 over 4. And now that we have dx dv, we can now go back to our chain rule and substitute. So our chain rule is dx dt is equal to dx dv multiplied by dv dt. And so dx dt is equal to dx dv, which is a quarter, multiplied by dv dt. dv dt we were given to be 2.4. So let's multiply that by 2.4 dx dt. Punch that into the calculator. That's 1 over 4 times 2.4, and you get 0.6. Note that this is in meters per hour, right? The reason we know that this is in meters per hour, if you go back to your question over here, we are given that the rate or water is being pumped into the tank at a constant rate of 2.4 cubic meters per hour. So if the volume is at cubic meters per hour, it means that the depth is in meters per hour. The question clearly states that it wants the answer in centimeters per minute, so we have to change our answer here, and to do that we can simply multiply dx dt is equal to 0.6 by 100 over 60, and if you punch that into your calculator, 0.6 by 100 over 60, that gives us 1. So that's 1.00 cm per minute. And this would be our final answer. Let's move on to question number 5. Show that the equation 4 sine x minus 3 over tan x minus 3 over sine x is equal to 0 may be expressed in the form a cos squared x plus b cos x plus c is equal to 0, where a, b, and c are integers to be found. Okay, so we've got 4 sine x minus 3 over tan x minus 3 over sine x is equal to 0. So we're going to start by using the identity tan x is identical to sine x over cos x to substitute this tan x over here. So that becomes 4 sine x minus 3 over sine x over cos x, and this is minus 3 sine x, and this is all equal to 0. So this becomes 4 sine x minus, if you resolve the fraction, you get negative 3 cos x over sine x minus, looks like I made a mistake over here. That sine x should be in the denominator, so it should be 3 over sine x here. So this bit would be 3 over sine x, and this is equal to 0. And now let's get rid of the denominator by multiplying through by sine x. So this becomes 4 sine squared x minus 3 cos x minus 3 is equal to 0. And now we're going to use the identity sine squared x is identical to 1 minus cos squared x to substitute the sine squared x over there, since we are trying to go to an equation in terms of cos x. So this becomes 4 times 1 minus cos squared x minus 3 cos x minus 3 is equal to 0, and so that's 4 minus 4 cos squared x minus 3 cos x minus 3 is equal to 0. Okay, and so this is negative 4 cos squared x minus 3 cos x, and we've got 4 minus 3, which is a positive 1, and this is equal to 0. Let's multiply through by negative 1 to make the coefficient of cos squared x positive. So that would be 4 cos squared x plus 3 cos x minus 1 is equal to 0. And this would be our final answer for part A. Okay, now part B says hence solve the equation. We are here. Hence solve the equation 4 sine x minus 3 over tan x minus 3 over sine x is equal to 0 for x is between 0 and 360 degrees. So to solve that equation, we're simply just going to be solving this equation that we proved in part 1. So that's 4 cos squared x plus 3 cos x minus 1 is equal to 0. We can factorize this, so that's 4 cos x, and we have cos x here, factors of negative 1. We're going to do a positive 1 over here and a negative 1, so that we're 4 cos x times 1, which gives us 4 cos x, minus cos x, which leads to 3 cos x. Okay, that works. And so that means we've got 4 cos x minus 1 is equal to 0, and we've got cos x plus 1 is equal to 0. And so here we'd end up with cos x is equal to a quarter. So x is equal to arc cos of a quarter. X is equal to, if you punch this into the calculator, and note that we are in degrees, arc cos of 1 over 4, that gives us x is equal to 75.522, that's a 48781. And then we're going to use the formula for cos, which is plus or minus PV plus 360n, to check if there are any other solutions within our given interval of 0 to 360. So we can do at n is equal to 1, at n is equal to 1. By now you should know that the negative PV will give you the correct solution. Negative PV plus 360 times 1. Our PV is this value, the value you get from the calculator from evaluating arc cos. That will be your principal value. So we're saying negative PV plus 360 times 1 should give us the value within our given interval. But of course, if you're not certain, you can also evaluate the positive PV solution, and you should notice that it's outside our given interval. So this is 284.5. That would be the other solution from here. So we'd get x is equal to 75.5 degrees, and we've got 284.5 degrees. Now let's come to the equation cos x plus 1 is equal to 0. That's cos x is equal to negative 1. So x is equal to arc cos of negative 1. X is equal to, let's punch that into the calculator, arc cos of negative 1 gives us 180 degrees, and that would also be a solution. And we can conclude that therefore our final answer is x is 5.5 degrees, 180 degrees, and 284.5 degrees. Let's move on to question number 6. The points A 60, B 66, and C -26 are on the circumference of a circle. Part A, find an equation of the circle. Okay, so let's draw a sketch of the circle. Alright, and let's say our center is somewhere here. We're given that A is the point 60. Let's assume that 60 is somewhere over here. So this would be our point A. And then we've got point B being 6, 6. Notice how they have the exact same x coordinate. So that means B should be somewhere above our A. So let's just say that B is over here. And then we've got C, which is -2, 6. Notice how B and C share the same y coordinates, which means they are at the same height. So C would probably be somewhere here. And if we join the points going from C to B and then from B to A and then A through to C, you can notice that we form a right angled triangle. And so we can tell that the coordinates of the center here should be the midpoint of AC. So let's find the midpoint of AC. So we've got the x coordinate of A being 6, and then the x coordinate of C is -2, and this is all over 2. And then we've got the y coordinate of A being 0 and the y coordinate of C being 6, and this is being divided by 2. So this means M has the coordinates, got 6 minus 2, which is 4 over 2, that's 2, and then 0 plus 6, which is 6 over 2, that's 3. So we know that the coordinates here are 2, 3. And now we also need to find the radius. So let's say our radius is the distance from our center to A. So if we calculate that length, we can say that the x coordinate of A is 6 minus the x coordinate at the center, which is 2, and this is squared, plus the y coordinate of A, which is 0, minus the y coordinate of the center, which is 3 squared. And so R is equal to, let's punch this into the calculator, that is the square root of 6 minus 2 squared plus 0 minus 3 squared, and that gives us R is equal to 5. And so this means that the equation of our circle must be x minus 2 squared plus y minus 3 squared, and this should be equal to the radius squared. So therefore the equation of the circle is x minus 2 squared plus y minus 3 squared is equal to 25, and this would be our final answer for part A. Now part B says find an equation of the tangent to the circle at B. Okay, so let's draw a tangent at B. Would look something like that. And now we know that a tangent to the circle is always perpendicular to the radius. So if I can, in fact, let me change the color. Let's get a red color. And we've got, this is the radius. And we know that our tangent at B should be perpendicular to the radius. So if we can get the gradient of this red radius over here, we can then use the idea that the product of the gradients of perpendicular lines is equal to -1, and that will allow us to evaluate the gradient of the tangent and therefore help us to get the equation of our tangent. So M, we're going to call this MR, that's the gradient of the radius. That's change in y, so we've got 3 as the y coordinate at the center, minus b has coordinates 6, 6, so that's 3 minus 6 over 2 minus 6. Let's punch this into the calculator. 3 minus 6 over 2 minus 6, that gives us 3 over 4. So this must mean that the gradient of the tangent is equal to the negative reciprocal of that, flip this fraction and make it negative, so negative 4/3. That's the gradient of the tangent. And we also know that our tangent passes through the point B. So using these two pieces of information, we can get the equation of our tangent. So we're saying y is equal to mx plus c, where we've got the point B, 6, 6, and the gradient m, negative 4/3. Let's substitute y is 6 is equal to the gradient, which is negative 4/3, multiplied by x, which is 6, plus c. So 6 is equal to, that is negative 4/3 over multiplied by 6. And that gives us negative 8, and this is plus c. So c is equal to 6 plus 8, which is 14. Therefore, the equation of the tangent is y is equal to negative 4/3 x plus 14. And this would be the final answer. Number 7. The diagram shows a sector OAB with center O and radius r centimeters. Angle AOB is theta radians. It is given that the length of the arc AB is 14.4 centimeters and the area of the sector OAB is 129.6 centimeters squared. So we are given that the arc length of AB is equal to 14.4, and we're given that the area of sector OAB is 129.6. So we can write this in terms of the formula. So that will be r theta is 14.4 and area of a sector is half r squared theta, and this is equal to 129.6. Now you notice that we have two equations in terms of r and theta, so we can solve them simultaneously. We'll make theta subject of the formula in our first equation. So that's theta is equal to 14.4 over r. And let's substitute it into the second equation. So half r squared multiplied by theta, which we said is 14.4 over r. And this is equal to 129.6. So this r will cancel with the squared. And so we've got half times 14.4, half times 14.4, that gives us 7.2. So this is 7.2 r is equal to 129.6. Divide both sides by 7.2. So 129.6 divided by 7.2, that gives us 18. So that means our radius is 18. Now let's evaluate theta. That's 14.4 over 18. If you punch this into the calculator, that is 14.4 over 18. That's 4 over 5, which we can write as a decimal as 0.8. 0.8. Now we have our values for r and theta. Now our actual goal is to get the area of the shaded region. So we can create an expression for that. We can say that our shaded region is equal to the sector area, that's OAB. So that's the whole pie-shaped thing, minus the white triangle that you see, minus triangle OAB. So this expression will give us that blue shaded region. And so we already have the sector area OAB, which was given as 129.6. So this is 129.6 minus the area of triangle OAB. We can get the area of triangle OAB by using the formula half r squared sine theta. Since we have our values for r and theta, we can simply substitute. That would be half times 18 squared sine 0.8. Okay, let's punch this into the calculator. 1 over 2, make sure you're in radians. 1 over 2 times 18 squared times sine 0.8, and this gives us 116.2117. That's correct to 4 decimal places. And we can now go back to our expression and substitute the area of the triangle. So we have 129.6 minus 116.2117. And if we punch this into the calculator, we get 13.4, and this is correct to 3 significant figures. So we can conclude that the area of the shaded region therefore is 13.4 centimeters squared, and this would be our final answer for part A. Now part B wants us to find the perimeter of the shaded region. Now if we can create an expression for perimeter, I'll write it over here. Perimeter would be equal to the length of the distance from A to B. So line AB plus the arc AB, because we're looking for perimeter from A to B and then this whole arc over here. That's what we are looking for. Now we already know that arc AB is 14.4, so we can say that our perimeter is equal to AB plus 14.4. To get AB, what we can do is we can split this triangle over here in half to form these two right-angled triangles. Now we know that theta is equal to 0.8, but we have split theta in two. It must mean this angle over here must be 0.4, and we know that our radius is 18 centimeters. And so we can say that our side here opposite the angle 0.4 is the opposite side, and we have the length of the hypotenuse. So that means that our opposite side here should be equal to 18 sine 0.4 using SOHCAHTOA. Okay, but we want the length of AB. What we have found here is half of AB, so it means we're going to multiply this expression by 2. So AB would be 36 sine 0.4. So we can come and say perimeter is AB, which is 36 sine 0.4 plus 14.4. And so perimeter is equal to, if we punch this into the calculator, 36 sine 0.4 plus 14.4, that gives us 28.4 centimeters, and this is correct to 3 significant figures, and that's our final answer. Let's move on to question number 8. The first term of a geometric progression is 64 and the fourth term is 27. Part A, find the sum to infinity of the progression. Okay, so we've got a GP, and we are given that the first term, A, is 64, and we are also given that the fourth term, U4, is equal to 27. So we can write U4 as AR cubed using the formula for nth term, and this is equal to 27. We know that A is 64, so this is 64 R cubed is equal to 27. So R cubed is 27 over 64. So R is equal to the third root of 27 over 64. So let's punch this into the calculator. That's the third root of 27 over 64. And this gives us 3 over 4. So now that we have our value for R, we can get the sum to infinity, which is A over 1 minus R. So A is 64 over 1 minus R is 3/4. And so our sum to infinity is equal to, let's punch that into the calculator, 64 over 1 minus 3 over 4, and this gives us 256, and this is the final answer for part A. Now for part B, we're told that the second term of a GP is equal to the second term of an AP. Okay, let's just write that down. So we have the second term of the GP is equal to the second term of the AP, and we are also given that the third term of a GP is equal to the fifth term of the same AP. Okay, so we are also given that U3 of the GP is equal to U5 of the AP, and they want us to get the sum of the first 10 terms of the AP. Okay, so under a GP, we can say that U2 is the same as AR, but since we're going to have to write A for the GP and A for the AP, I'll just write this as AGP so that we don't confuse the two A's. So this is AR is equal to, under an arithmetic progression, U2 is A plus D. So I'll write an AP there so we don't confuse. And then U3 under a GP, that's AGP. And this is R squared. And this is equal to U5, which is A plus 4D. Now remember that we already have the values for the GP from part A. We know that our R is 3/4 and our A was given in the stem of the question to be 64. So we can come back here and substitute the information we have for the GP. So A is 64, R is 3/4. So this becomes 64 times 3/4 is equal to A plus D. And then here we've got A times R squared. So 64 times 3/4 squared is equal to A plus 4D. Okay, so let's just simplify. Let's start with 64 times 3/4, and this gives us 48. So we've got 48 is equal to A plus D. And then let's simplify 64 times 3/4, and that is squared. That gives us 36. And this is equal to A plus 4D. Now we have two equations in terms of A and D. We can solve them simultaneously. So we're going to make A the subject of the formula here. That becomes 48 minus D. Let's substitute this into the second equation. So 36 is equal to A plus 4D. So A is 48 minus D. 48 minus D plus 4D. So this becomes 36 is equal to 48. We've got minus D plus 4D, which is plus 3D. And so we've got 3D is equal to 36 minus 48, which is negative 12. Divide both sides by 3. You get D is equal to negative 4. Now let's use that information to evaluate A. So A is 48 minus D, so that's 48 minus 4, which is 48 plus 4, so A is equal to 52. And the question wants us to find the sum of the first 10 terms of the arithmetic progression. So we're going to use the formula half n times 2a plus n minus 1d. So that's half times 10 times 2a being 52. 52 plus n minus 1, that's 10 minus 1 times d, which is negative 4, and then let's close that bracket. So this is the sum of the first 10 terms. Let's punch that into the calculator. Half times 10 times, that's 2 times 52 plus 10 minus 1 times negative 4, and this gives us 340, and this would be our final answer for number 8. Now let's move on to question number 9. The function f is defined by f of x is equal to 1 plus 2 over x minus 3 for x is greater than 3. Part A, state the range of f. Okay, so f is a rational function, and you should know that the graph of a rational function stems from the graph of y equals 1 over x, and that graph looks like this. This is the graph of y equals 1 over x. But to get to the graph for f of x here, we have to apply a few transformations. So I'll just change the color to red. Okay, so we'll start with this minus 3 over there. That's a translation in the x-axis by 3 units. So 3 would be somewhere here. Going to draw a dotted line through here. And then we have this 1 here, which is a translation in the y direction. So 1 would be somewhere here. And that's by 1 unit. Notice that our domain is x is greater than 3. So it would mean, instead of drawing both graphs like this, it would mean we're only drawing this graph over here on the right hand side. And we know that this line here is y is equal to 1. And we can tell that our function is increasing, going upwards. Therefore, we can state that our range for f is f of x is greater than 1, and that would be part A. Now part B says obtain an expression for f inverse of x and state the domain of f inverse. Okay, so we know that f of x is equal to 1 plus 2 over x minus 3. So let's replace f of x with y. So this becomes y is equal to 1 plus 2 over x minus 3. Now our goal is to make x the subject of the formula. So let's move this 1 to the left hand side. So y minus 1 is equal to 2 over x minus 3. And we can write this as x minus 3 is equal to 2 over y minus 1. And now we simply add 3 to both sides. So x is equal to 3 plus 2 over y minus 1. And that's our inverse. Let's write it with the correct notation. F inverse of x is equal to 3 plus 2 over, remember to then change this y to an x minus 1. And we were told to state the domain of our inverse. We know that the domain of the inverse is equal to the range of the original function. So that would mean our domain is x is greater than 1. And this would be our final answer for part B. Okay, now part C says obtain a simplified expression for g(f) of x. We'll do it on top here. So let's just write out the two functions. First, f of x is 1 plus 2 over x minus 3, and then g of x is equal to, that's 4x minus 4, and we want g(f) of x. Okay, so that's 4, and then wherever there's an x, we're going to replace it with the f of x. So that means we'll put a big bracket here and replace this x with f of x. So that's 1 plus 2 over x minus 3. Then let's close our bracket. Then we have the minus 4 over there. So g(f) of x, if we expand, we've got 4 times 1, that's 4. Then 4 times 2 here, that will be plus 8 over x minus 3 minus 4. And the 4 will cancel out with the negative 4, and so you end up with g(f) of x is equal to 8 over x minus 3, and that would be the final answer. Let's move on to number 10. At the point 436 on a curve, the gradient of the curve is 57 over 8. It is given that dy dx is equal to x to the negative 3 over 2 plus k, where k is a constant. Part A, show that k is equal to 7. Okay, we are given that the gradient function dy dx is equal to x to the negative 3 over 2 plus k. And we're given that at the point 436, the gradient, in other words dy dx, is equal to 57 over 8. So at x equals 4, dy dx is 57 over 8. We can substitute that into this equation over here to evaluate k. So that would become 57 over 8 is equal to, we said x is 4, so that's 4 to the negative 3 over 2 plus k. And so this is, what's 4 to the negative 3 over 2? That gives us 1 over 8. So we've got 57 over 8 minus 1 over 8 is equal to k. So 57 over 8 minus 1 over 8. And that gives us k is 7. And that would be the proof for part A. Now part B says find the equation of the curve. Okay? So we now know that dy dx is equal to x to the negative 3 over 2 plus 7. We can integrate, so that will become y is equal to, and then here we've got x to the negative 3 over 2. Let's add 1 to negative 3 over 2. We get negative half. Let's divide by negative half. And this is plus 7, that will become 7x plus a constant of integration. So y is equal to, that's negative 2x to the negative half plus 7x plus c. Now remember, we're given the point 436. We are given the point 436 over here. We can use that to then evaluate c. So we know that our y value is 36 and x is 4. This is to the negative half plus 7 times 4 plus c. So 36 is equal to, we've got, that's negative 2 times 4 to the negative half, and this is plus 7 times 4, and that gives us 27 plus c. So c is equal to 36 minus 27, which is 9. Therefore, we can conclude that the equation of the curve is y is equal to negative 2x to the negative half plus 7x plus 9. And that will be the final answer for part B. Now part C says find the coordinates of the stationary point. So to get the coordinates of a stationary point, we equate dy dx to 0. And we know that in our case, dy dx is x to the negative 3 over 2 plus 7, and this is equal to 0. So this would become x to the negative 3 over 2 is equal to negative 7. And then we can write this as x is equal to negative 7. That's to the power negative 2 over 3. X is equal to, let's punch this into the calculator, that's negative 7 to the negative 2 over 3. And that gives us 0.27327588833. This is the calculator display. And now we need to evaluate the y coordinate. And we are going to use the equation of the curve. Y is equal to that. So that's negative 2. I'll just use 4 decimal places here. So I'm going to use 0.2733. This is to the negative half plus 7 times 0.2733 plus 9. Y is equal to, so this is negative 2 times 0.2733 to the negative 1 over 2 plus 7 times 0.2733 plus 9, and this gives us, this is 7.09. So you can conclude that the coordinates of the stationary point are 0.273 and 7.09, correct to 3 decimal places. And now part D says determine the nature of the stationary point. To get the nature of a stationary point, you have to find the second derivative. So we know that dy dx is equal to x to the negative 3 over 2 plus 7. So d squared y dx squared is equal to, we're going to drop down the power, so that's negative 3 over 2 x, subtract 1 from the power, so it becomes negative 5 over 2, and then there's a constant, so it becomes 0. And we want to evaluate at x is 0.273, so this is negative 3 over 2 times 0.273, and this is to the power negative 5 over 2. Let's punch that into the calculator. Negative 3 over 2 times 0.273, and this is to the power negative 5 over 2, and this gives us negative 38.5. Since our second derivative is negative, we can conclude that since d squared y dx squared is less than 0, the point 0.273, 7.09 is A. That's a maximum point. And this would be our final answer for D. Now let's move on to question number 11. The diagram shows, or that's supposed to be curves. The diagram shows curves with equations y is equal to 2x to the negative half plus 6 and y is equal to 2 times x to the half plus 3x to the negative half. The curves intersect at points A and B. Part A, find the coordinates of A and B. So in part A, we're simply solving for points of intersection. We've got y is equal to 2x to the negative half plus 6, and we've got y is equal to 2x to the half plus 3x to the negative half. Okay, so let's equate the two equations. 2x to the negative half plus 6 is equal to 2, that's x to the half plus 3x to the negative half. Let's divide both sides by 2, so this would be x to the negative half plus 3, and then we get rid of this 2, so this becomes x to the half plus 3x to the negative half. And now let's put everything on one side, so we're going to move this to the right hand side. So we've got x to the half plus 3x to the negative half. Then this becomes negative x to the negative half, and then we've got negative 3. This is equal to 0. Okay, so we've got x to the half, and then these are like terms here, so that becomes plus 2x to the negative half minus 3 is equal to 0. Now I'm going to write this term with a positive power, so that's x to the half plus 2 over x to the half minus 3 is equal to 0. Let's get rid of the denominator. So this would become x to the half times x to the half, which gives us x. And then we get plus 2 minus, this is 3x to the half, and this is equal to 0. If we arrange it in order of descending powers of x, it would look like this, and this is equal to 0. Now this is a hidden quadratic, so to make that visible, I'll write this x in terms of x to the half, so it would be x to the half, and squared using laws of indices, half times 2 gives us 1, and the power here is in fact a 1. Okay, and we've got minus 3x to the half plus 2 is equal to 0. Then we're going to say let y equal x to the half, so that you can clearly see that this is a quadratic. and substitute every instance of an x to the half with a y. So that would become y squared minus 3y plus 2 is equal to 0. And now we can clearly see our quadratic. And let's factorize our quadratics. We want factors of 2 that add up to -3. So that's -1 and -2. So this means y is equal to 1 and y is equal to 2. Now let's use our substitution to go back to x. We said y is x to the half. So this means that x to the half is 1 and x to the half is 2. To get x, we're going to simply square both sides. So x is equal to 1 squared, which is 1. And then we've got x is equal to 2 squared, which is 4. That means that our x coordinates are 1 and 4. We also need to evaluate our y coordinate. Okay, so we can use one of the two equations. We're going to use this equation. That's y is equal to 2x to the negative half plus 6. It probably wasn't the best idea to use y for the substitution. We probably should have used another letter to avoid the confusion. But we're using y is equal to, that's 2x to the negative half plus 6. 2x to the negative half plus 6. Okay, so at x equals 1, y is equal to 2 times 1 to the negative half plus 6. So that's y is equal to 8. And then at x is equal to 4, you get y is equal to 2 times 4 to the negative half. And this is plus 6. So if you punch this into the calculator, 2 times 4 to the negative half plus 6, that gives us a 7. Okay, and so this means that the coordinates of a and b are a is 1 8 and then b is 4 7, and this would be the final answer for part A. Now if we go on to part B, it says hence find the area between the two curves. Let's do that over here. Area between the two curves would be integration, and we say that the x coordinate there is a 1 and then the x coordinate there is a 4. So it means we're integrating from 1 to 4 and we're subtracting the lower curve from the upper curve. So we're saying the blue curve minus the red curve. So that's 2x to the negative half plus 6 minus our red curve. I'm just going to multiply it through by that 2. So that would be 2x to the half plus 6x to the negative half. Okay, so this would be 2x to the half plus 6x to the negative half, and this would all be with respect to x. So we are integrating from 1 to 4. That's 2x to the negative half plus 6. Let's expand our bracket. Negative 2x to the half, negative 6x to the negative half, and this is with respect to x. And now let's simplify like terms. We have like terms over here, 2x to the negative half minus 6x to the negative half. So that's 1, 4. That would become negative 4x to the negative half. And then we've got a negative 2x to the half. And then we've got a plus 6. And this is with respect to x. Okay, so now we can integrate. If we add 1 to our power over here, this is negative 4x, that would now become a half. So that means we are dividing by 1 over 2. And then minus, we've got 2x. If we add 1 to half, you get 3 over 2. So we're dividing by 3 over 2. And then we've got plus 6x. And this is from 1 to 4. Okay, so this is negative. We've got 4 over half, which is 4 by 2, and that's 8. So negative 8, that's x to the half. And then we've got negative 2 divided by 3 over 2. That gives us a negative 4 thirds x to the 3 over 2. Then we've got a plus 6x, and our limits are 1 and 4. Now we can go ahead and substitute our limits. So let's start with the upper limit. So that would be negative 8 times 4 to the half minus 4 over 3, 4 to the 3 over 2 plus 6 times 4. Let's close the bracket. Now let's go on to the lower limit. That's negative 8 times 1 to the half minus 4 over 3 times 1 to the 3 over 2 plus 6 times 1. Okay, let's punch this into the calculator. We're going to start by evaluating this bracket over here. So that's negative 8 times 4 to the half minus 4 over 3 times 4 to the power 3 over 2 plus 6 times 4, and that gives us negative 8 over 3, and then we have this minus sign, minus, let's evaluate the lower limit, negative 8 times 1 to the half minus 4 over 3 times 1 plus 6 times 1, and that gives us negative 10 over 3. And so this is the same as 10 over 3 minus 8 over 3, and this would give us 2 over 3. So we can conclude that therefore the area between the two curves is 2 over 3. Okay, so that's it for the guest paper. I hope you guys found some value from it. If you did get value from it, please consider liking and subscribing to our YouTube channel. Thank you for watching. See you tomorrow at 6 p.m. for the final tips video in preparation for your Pure 1 exam. Bye bye.